All right, so today I'm just going to show a couple of examples from level 2 problems or level 3 problems from section 5.3. And I'm just going to write the problems down and I'm going to work through a couple of them. Again, these are upper level problems from section 5.3, and these would be the ones that I would think that most kids would tend to struggle with a little bit. And they require the most honors pre-calc knowledge in terms of Algebra 1, Algebra 2 standards. Okay, so the first one that I'm going to tackle is actually on page 376 and page 377. And so the first thing I want to do, and I'm not going to use the graphing calculator ones, so we don't want to compare with the graphing calculator. We want to be able to solve without them. And so what I want to do is using page 360 or 376 and page 377, we want to take a look at the first one that I want to take a look at is number 61. And that one says that the cosine of x over 4 is equal to 0. Now, rather than memorize a formula or multiple angle item, what I want to do is in my head, in my thinking bubble, I want to be thinking theta is my angle. Okay, so in this case, x over 4. So in my head, what I'm really thinking is, where is the cosine of theta equal to 0? So in my head, I come over here now, and in my head I'm thinking, well, the cosine of 0 is 0 at pi over 2 and 3 pi over 2. And the same rule today, we're going to go from 0 to 2 pi, because we just want to go one loop around the circle. Okay? So, okay, the cosine of something is 0 when that something is equal to pi over 2 or 3 pi over 2. Now, I'm going to write out some other numbers here because I want to make sure that I stay within that 0 to 2 pi. So I'm just going to write the next one would be at 2 pi from here, so at 5 pi over 2, and then it would be 2 pi from here, so 7 pi over 2, ... right? On and on forever. Now, theta is what I was looking at. But theta is not just theta right now. Theta is equal to x over 4. And even in Algebra 1, when we were solving for x's, the way we did that was we solved for x equals, okay? And so if that's true, then I need to back up because I don't have x. I have 1/4 of x, see? So I need to multiply everything by 4. So all of these numbers are now going to be multiplied by 4. And if I do that, I get 2 pi, I get 6 pi, I get, 10 pi, and on and on and on. Well, that's great, but notice I never actually got an answer that's within my window. So of the possible answers that I had, not one of them was inside my window. So for this problem, there's actually no solution. If I answer the question the way it's written, from 0 to 2 pi, then I would have no solution. Now, if I extend the window, and I say, hey, I want you to go from 0 to 4 pi. If I do that, then I have one answer, and it would be x equals 2 pi. So the thing that I want you to be paying special attention to is the window. And again, I'm telling you, for us, we're going to be looking at 0 to 2 pi. Okay, and we're not going to count 0 line twice. So we're counting 0, but not at 2 pi. All right, let's do another example. And I'm going to do a couple, so I want you to see the differences. Okay, the next one I'm going to do is actually number 64. In fact, I'm going to switch that. I lied. I'm going to go with 66 because I don't want to do another cosine like that. So I'm going to do this one. The secant of 4x is equal to 2. Okay, the secant of 4x is equal to 2. So now in my thinking bubble, I'm thinking, where is the secant equal to 2? And now this should look like 5.3 day 1 problem, where you went, okay, well, this is really 1 over cosine. So I do a little bit of algebra, and I get that the cosine of theta is equal to 1/2. So in my head, I'm really thinking that the cosine of something is equal to 1/2. That's what this is telling me. So then I come over here and I say, okay, well, that's something. I don't know what it is just yet. But now I'm thinking this. Where is the cosine of theta equal to 1/2? Well, it's got to be positive. So that's going to happen at pi over 3, and then at 5 pi over 3, and then 2 pi from here, right, which would be 7 pi over 3, and then 2 pi from here, and that would be at 11 pi over 3, and on and on and on. Remember, this is plusing 2 pi to the original value. And so the reason I'm doing this now is because I need to show you what's going to happen on the upper level problems. Now, again, I'm going to cut my window from 0 to 2 pi. I'm always cutting that, especially for the quest. So in this case, though, I don't have just theta. I have 4x, so I have to put 4x in here. And remember, we don't solve for 4x. We need to solve for x. So now I'm going to take all of these numbers and I'm going to divide by 4. All of them and divide by 4. Okay? And that's really what I want to take a look at is how does that happen? And so pi over 3 divided by 4 is the same as saying times 1/4, times 1/4, times 1/4. And so now I want to go, oh, well, this is going to happen at pi over 12, and then it's going to happen at 5 pi over 12. And then it's going to happen at 7 pi over 12, and then 11 pi over 12. And now remember that each of these answers up here, 5 pi, 7, 11, all of those happened every 2 pi, correct? But I'm now having to divide by 4. And so that throws a wrench in my plan because at this point right here, at 7 pi over 3, I'm actually past 2 pi. But if you come down here, I am not past 2 pi yet. And so now I'm going to stop looking up here, and I'm going to look here, and I want to say, okay, what's the pattern? The pattern is plus 4, plus 2, plus 4. Guess what? Plus 2. My bad. So look, plus 4, plus 2, plus 4, plus 2, plus 4, plus 2, plus 4. And now I'm done because I'm going to go over 2 pi. So it turns out that instead of having, look at this, I'm going to show you a pattern. Instead of having the 2 answers, I actually have 1, 2, 3, 4, 5, 6, 7, 8. Look at, instead of 2 answers, I have 8 answers. I have 4 times as many answers as I would have had, okay? That pattern recognition is useful when you have a multi-angle formula. Let me do one more of these. This is number 68, and the reason I want to do 68 is it's an alternate version because we have a squared quantity. Okay, and so what I want to remember is when you have the squared quantity, I don't touch this inside. Okay, do not touch the inside until the last step. So I'm going to square root both sides, and when I take a square root, I have to put a plus or minus. And now what I'm saying is the tangent of 3x is equal to plus or minus square root of 3. So remember, I'm now thinking. These questions require us to think. I know, it's painful, but do it. I'm really thinking, where is the tangent of theta equal to the square root of 3? And that can be either plus or minus. Well, I'm thinking now, tangent is sine theta over cosine theta. And I want the square root to be on top. So that would be like the square root of 3 over 2, those angles where the sine is bigger. Okay, well, let's see. Thinking bubble still. I'm still thinking about the answers. Well, that would be, let's see, where the sign is bigger. So first loop around the circle would be pi over 3. And then it would be at 2 pi over 3. And then it would be 4 pi over 3. And then it would be 5 pi over 3. Then it would be 7 pi over 3. And then it would be, let's see, the pattern is add 1, add 2, add 1, add 2, add 1, add 2. Okay, so for those of you who are listening to my words, notice the difference between 1 and 2 is a plus 1. And the difference between 2 and 4 is a plus 2. The difference between 4 and 5 is a plus 1. The difference between 5 and 7 is a plus 2. Look, 1, 2, 1, 2, 1, 2. So in my head, I'm doing this. Okay. Now, to finalize my answer, remember, I'm looking where? Say it. Please say it. 0 to 2 pi. My answers cannot exceed 2 pi, and they must be positive. So now I come over here and I go, but wait, I'm saying 3x is equal to these numbers, pi over 3, 2 pi over 3, 4 pi over 3. And I'm just going to write as many as I think I need. I know how many I need, but I'm going to keep writing. Because what's going to happen is I'm now going to come over here and I'm going to divide everything by 3. And remember, when we divide fractions, we flip and multiply, flip and multiply, flip and multiply, flip and multiply. Okay? So x equals, my final answer, just like Algebra 1, x equals pi over 9, 2 pi over 9, 4 pi over 9, 5 pi over 9, 7 pi over 9. And now I'm going to keep following the pattern. Remember, plus 1, plus 2, plus 1, plus 2. I better stop before I get to 18 pi over 9, because that would be my 2 pi. So stop before you get here. And so now I'm just going to keep going with my pattern. So remember, plus 1, plus 2, plus 1, plus 2, plus 1, plus 2, plus 1, plus 2. I was saying plus 2. Plus 1, plus 2. Plus 1. And stop. Now, I want to think about this for a second because that looks like a lot of answers. And granted, on the quest, I will probably not give you one that has this many answers. But let me point something out to you. We're talking about tangent, and we had a plus or minus root 3 over 2, which means in one loop around the circle, we would have hit it once, twice, 3 times, 4 times. We would have had, in our bubbles, remember, we would have had 4 answers. I should have 3 times that. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, Miss Collins, you're so smart. I know. Not only that, it looks so much easier when I do it. Yes, because I'm doing it. So what I want you to do is I want you to tackle a couple of these on your own. I want you to tackle them because these multi-angle problems are extremely difficult, okay? So I know they're going to take some time. I'm expecting that you would watch this video and that you'll do a couple of them on your own, okay? So 61 through 72 are all multi-angle problems, and they're all going to be modeled the same way. Tomorrow when you come into class, we are going to do a couple of examples from 25 through 34 together, and then we're going to take a look at a couple of 35 to 48. But again, we are not using a calculator. We are doing all of this with the memorized values, okay? So, happy solving. Good luck.